Hey there, Kipsters. We're looking at objectives 2B.7 through 10. That's solving two-step inequalities. So those are things that are not equal, such as less than, greater than, less than or equal to, or greater than or equal to. You're going to see the steps are really similar to what we did before. To begin with, I want to talk about how we're going to graph inequalities to make sure that you understand what a statement like x is less than 5 actually means. So the different types of inequalities you'll see are, again, less than or equal to, and greater than, or greater than or equal to. Greater than or equal. So what I want to do is graph different statements so that later when I actually solve inequalities, I understand what the values of x could be. So in this first one, let's say I have x is greater than or equal to 1. If I want to graph that, I'm going to put a circle at 1. And I know if it's greater than or equal to 1, that means it can be all the values that are greater than 1. It can be any of these numbers. And it can also be 1. So I'm going to shade in 1. And so that's x is greater than or equal to 1. The emphasis is I'm shading in the circle since it can equal 1. Another example, if I have x is less than 2, if I want to graph that, I'll put a circle at 2. But it can't equal 2, so I'm not going to shade in 2. It can only be values that are less than 2. And so it can be any of these values, but it cannot be 2. So that's how you would graph x is less than 2. Okay, stop the video here because on your paper I'd like you to graph these two inequalities. First, x is less than or equal to 3, and then x is greater than negative 2. Go ahead and graph those on your paper. Okay, you graphed them, so it's now time to check. X is less than or equal to 3. That means you put a circle at 3. Since it can equal 3, you should have shaded in that circle. It can equal 3. It can be anything less than 3, so that's all these values. Next, x is greater than negative 2. That means you put a circle at negative 2. It cannot equal negative 2, so you don't shade it in. It can only be the values that are greater than negative 2, and that's these. Okay, so now we're clear on what you would actually graph and what values x could be, because x can be any of these numbers, can be any of these numbers, any of these numbers, any of these numbers. So that when we actually solve inequalities, you will know what the answers can be. Now, I want to actually solve first one-step inequalities. So, bottom line for solving one-step inequalities is it's the same thing as solving one-step equations. The only difference is, instead of x having one answer, like x equals 5, x can have many values, such as x is less than 5. There'll be multiple answers that it could be. Because if x is less than 5, it could be 4, 3, 2, 1, 0, negative 1, etc. So to solve this inequality, x plus 4 is less than 10. I'm going to draw a line down where I have the inequality sign, and I'm going to add the opposite just like we would in other cases. So I'm going to add negative 4 to cancel the constant, add negative 4 to cancel the constant, and that means x is less than 6. To check my answer, I'm just going to substitute in. X plus 4 should be less than 10. I cannot substitute in 6 because x is not equal to 6. I can substitute something smaller than 6, such as 5, and see if that's less than 10. 5 plus 4 is 9. 9 is less than 10, so my answer checks out. One more example. If I have 9 is greater than or equal to 3x, I'm going to solve it by canceling my coefficient, which is dividing by 3. And that means 3 is greater than or equal to x. The one important thing here though is the way I said it, 3 is greater than or equal to x, means that x is less than or equal to 3. I'll say that one more time. If 3 is greater than x, that must mean that x is less than 3. So if you flip it around because you want to put x first, that means actually the sign flips as well. But that's my answer, x is less than or equal to 3. To check my answer, that means I need to substitute in something that's less than 3. So for example, if I substituted in 1, 3 times 1 should be less than or equal to 9. 3 times 1 is 3. 3 is less than or equal to 9. 9 is greater than or equal to 3. So my answer checks out. I'm going to stop the video here. I'd like you to try C and D. Press play when you're ready to check your answer. Okay, I'm moving this up so I have some workspace. Time to check your answer. X minus 10 is less than or equal to 14. That means, to cancel the constant, you add 10. That would be x is less than or equal to 24. That should have been your answer. To check it, all you do is substitute in. If x is less than 10, you can substitute in something that needs to be less than 24. So for example, 20. 20 minus 10 should be less than 14. I'll do this in green so you can see it. 20 minus 10 would be 10. 10 is less than 14. The answer checks out. Next, D, x divided by 2 is greater than 10. So to cancel the coefficient, you multiply by 2. Again, reviewing one-step equations. That means x is greater than 20, and that should have been your answer. To check it, substitute in a value that's greater than 20. So I can't put in 20, I could put in 22. 22 divided by 2 is 11. 11 is greater than 10. My answer checks out. So that's how you solve a one-step inequality. The rules are exactly the same so far as how you would solve a one-step equation. The only difference is when you substitute in an answer. So this step is you can't always substitute in the actual value. You need to use sometimes a different number. There's one really important exception to this rule, which is what happens when you're solving a one-step inequality and you have a negative coefficient. So if I'm looking at A, I'm going to solve this just like I would solve an equation by canceling my coefficient by dividing by -3, dividing by -3. My coefficients cancel, and x on this side, -3 on this side. The one important thing here is the inequality sign flips. And very simply, the inequality sign will flip when you have a negative coefficient, which means you will multiply or divide by a negative number. So flip the inequality sign whenever you multiply or divide by a negative number. To check my answer, x is less than or equal to -3, so that means when I substitute in, x could be -3. So I'll actually substitute in -3, and it should be greater than or equal to 9. I'm using my original inequality to substitute it in. -3 times -3 is 9. 9 is greater than or equal to 9. My answer checks out. So again, the key difference here is the sign flipped because we divided by a negative. One more example. If I'm looking at B, I want to solve x divided by -2 is greater than 14. You should see that my coefficient of -2 is a negative number. So to solve this equation, or inequality, I'm going to multiply both sides by -2. My coefficients cancel, and x on this side, -28 on this side. But since I had a negative coefficient and I multiplied by a negative number, my sign flips from greater than to less than, and x is less than -28. To check my answer of x divided by -2 should be greater than 14. I'll substitute in a value. X has to be less than -28. So if I'm looking at the number line, a number that's less than negative 28 would be negative 30, for example. Negative 30 divided by negative 2 is positive 15, which is greater than 14, and my answer checks out. I'm going to stop the video here. I'd like you to stop the video. Please try C and D, and check your answer, and press play when you're done. Okay, for the sake of space, I moved that around. Now time to check your answer. Negative 12x is less than 36. You needed to divide by negative 12, divide by negative 12. And that means you have x on this side because the coefficients cancel. 36 divided by negative 12 would be negative 3. And since you had a negative coefficient and you divided by a negative number, it becomes x is greater than negative 3. To check D, you have 4x is greater than 16, so you divide by 4, divide by 4. 4 divided by 4 cancels, and this is x. 16 divided by 4 is 4, but the coefficient is not negative. And since you did not divide by a negative number, the sign should have stayed the same. Okay. So that one's different than the other ones on the slide. I'm just trying to make sure that you're paying attention. Hope you got it right. Last practice slide is how you're going to solve two-step inequalities, which is again combining your skills of solving two-step equations, but just with that additional rule of flipping the sign and that additional rule of how you're going to substitute and check your answer. So I'm going to solve A, and I'm going to ask you to do B, C, and D for guided practice. If I look at A, 14 is greater than 3x minus 4. I'm going to draw the line down where the inequality sign is. I'm going to first kill subtraction, and then I'm going to solve it just like I would have solved an equation. First, kill the constant, or cancel the constant, by adding the opposite. That means 3x is less than 14, 18. If I divide by 3 and divide by 3, my coefficients cancel. And that means 6 is greater than x. Remember, if I want to have x first, I can rewrite this as x is less than 6. Because if 6 is greater than x, that means x is less than 6. And that's my answer. I'd like you to try B, C, and D here. Please try it on your paper and stop the video. Press play when you're ready to check your answer for these last three. Okay, you've tried them, so now it's chance to check. To solve this, add the opposite. Constants cancel, so it's negative 2x is greater than 6. Then cancel your coefficient, which is divided by negative 2, divided by negative 2. Coefficients cancel, but since you divided by a negative number, the inequality sign should have flipped, and it should have been x is less than negative 3. Next, C, x divided by 2 minus 4 is less than or equal to 3. Draw a line down where the inequality sign is. You need to add 4. Add 4 to cancel the constant. You have x divided by 2 is less than or equal to 7. Cancel the coefficient by multiplying by 2. By multiplying by 2. Since it's a positive number, the coefficients cancel and x is less than or equal to, the sign stays the same, 14. And last one for you to check. 2x plus 10 is greater than 16. First, cancel the constant by adding the opposite of the constant. The constants cancel, and you have 2x is greater than 16. Cancel the coefficient x, divided by 2, divided by 2. And that means x is greater than 8. So at this point, you've had guided practice solving one-step inequalities without any signs flipping, one-step inequalities when the sign flips, and two-step inequalities. You should be ready to tackle this independent practice. You have 5 problems here, some of them one-step, some of them two-step. Please solve them, submit your answers. If you get your blue ribbon on these, you should be ready to retake objective assessment 2B.7 through 10. Good.